Okay, one of the things I've been asked recently is whether it's possible to dimension a profile, dimension and tolerance a profile as opposed to a standard geometric feature like a line or a circle. The answer is yes, but because it's not a standard geometric feature, we need to first import a DXF which defines the perfect profile of the part, which would have been created in CAD. And that allows us to compare a scan of the part to the DXF to establish what the profile error is. So first I'm going to import the DXF. If we come up to the top of the part view, you can see a DXF icon there. If I click on there, I have got my DXF import and export options. DXFs can be used for many different things in Fusion software. So first we have to define what we're going to do with this DXF, and on this occasion I'm going to import it as a curve profile. Next I can define the tolerance that I want to bring in with this DXF. So let's apply a general tolerance of say 50 microns. This can be edited later and can be changed for each section of the DXF if there are multiple tolerances present. So let's browse to a location now. If I go to my DXF location, I'm going to select a particular DXF, and then if I OK, in my part view, depending on where the machine is currently located, we may have to zoom out or zoom in to find where the DXF is. I can see it's up in this region, so if I zoom in, you can see that I've imported a DXF. If I zoom in on this file, you can see that the imported file is drawn as a nominal line. That's the red line, which is the perfect profile of the part as defined in CAD. And in either side of that line is the plus or minus tolerance of 50 microns that I defined on the import form. As I said, this can be edited at any point. Let's zoom out a little so we can see all of the part. So next I need to scan the profile section of the part of interest. So I'm just going to bring my camera window into view for the video, and here's the part. And what I'm going to do, instead of using a line, arc or a circle tool, I'm going to use the curve freeform scanning tool. So this enables any profile shape to be followed by the software. What I have to do is define a start point, a direction and an end point. So first of all, let's define a start point. I'm going to left click on the edge at the point where I want the scan to start. One click, and now you can see that I have a leader line attached to that central point that I clicked. That is to enable me to define the width of the tool, and that needs to be quite short and perpendicular to the direction of the edge. So I'm going to make a second left click to define that width. Now I've got the start point defined, I need to define the direction of scan. So either side of the tool I'm going to make a click, and I'm going to click on this point here. So we're going to scan north of that start point, and let's say we wanted to scan around about to this point. The last click I'm going to make is to flag the end point of the scan. So if I make a click there, you can see that the system then makes a scan. In this case there was 106 data points collected. As you'll probably know, that the density of the points can be defined, so we can cover that on another clip, but needless to say that could have been several hundred points if needed. So I'm going to OK that now and go back to the part view, and if we zoom out you'll see that because there's no alignment yet, well, let's first of all, there's my scan. You can see there's my 106 data points, and you can see that represents the profile of the part. Elsewhere in this part view, because there hasn't been a fit done yet or an alignment, we'll find somewhere else the DXF present there. So what I'm going to do now is open a function called grid shift. Grid shift allows translations and rotations to occur, and when this form is open, I have a tool which enables me to right click on the data cloud and drag and release, and that gives the data an equivalent translation, which is scaled by the part view. So what I'm trying to do is just to basically drag that data somewhere close to the position where the DXF was imported. Then I can zoom in, and we start to see that I'm close, and there's obviously something of a Z rotation that needs to be done there, but as we cross the data over the vicinity of the DXF, you can see as the data comes into tolerance, it turns green, and those data points which are out of tolerance remain red. So rather than manually try and adjust this, I've got it pretty close. I'm just going to ask the software now to do a final fit. So if I'm just going to tick the DXF box and ask the software to find the best fit to fit this cloud of points onto that DXF as close to the nominal as possible. Start, and you can see a very quick calculation, and it snaps that data cloud right onto the nominal line, and you can see at a glance that all of the data points are green, so therefore all of my points are within the 50 micron tolerance. So having made the best fit, you can see that all of the data points now are within the tolerance line, and they show in green, which means that all of those points are in tolerance. Any that are out of tolerance would be red. So visually we can see that that's a good part. If we wanted to dimension that result, however, and then apply a tolerance to it, we would need to apply a formal dimension. So with geometric tolerancing switched on, I need to select the curve twice by left-clicking twice, and that gives me a dimension, the beginning of a dimension. If I right-click and select Profile, then I can left-click to drop that dimension onto the part view, and you can see that the profile is actually reported now, and the error in this case is 3 microns. So that means that the point which is furthest away from the nominal line in that point cloud is a distance of 3 microns away. So every point within that point in that point cloud is within 3 microns of the nominal line. So that's the profile error. If we wanted to classify that error as a pass or fail, just like with every other dimension, if we right click on the dimension line as such, we open the dimension details window. The profile error is a geometric tolerance, so you can see here that this is where the result is displayed, and the standard, in this case the default geometric limit which is applied to the dimension happens to be 50 microns. That happens to be the same value as I applied to the DXF itself, but I'll demonstrate how that doesn't need to necessarily be the same number. If I was to change this tolerance to, say, a very small tolerance in this case, because the fit is so good, of 2 microns, you can see that this field has immediately turned red. So if I OK that now, having applied a 2 micron geometric tolerance to this dimension, we can see at 3 microns it's red and it's failed. So that is independent of the color coding that works within the graphical view. If I wanted to change the tolerance, the visual tolerance, I can right click on the nominal line of the section in question, and that shows me the tolerance that was applied at the point where the file was imported. So if I change this 50 micron tolerance to, let's say, 10 microns, you can see in this particular section the tolerance band has been narrowed right the way down. So in order to select that in an area of interest, I'll just zoom in first so I can right click on the line. Let's change this one to 10 microns, and you can see that in this case the DXF has been drawn in several sections, so I'd need to change the tolerance for each of those sections. So having reduced the tolerance band in some of the sections, it may be possible or may be necessary for me to now do a refit. So just to remind you, back to grid shift, we could then ask the software to do a refit if any of these data points now became out of tolerance. We would refit, giving more priority to the narrower tolerance bands. Okay, scanning and best fitting and dimensioning. Once the dimension has been applied, obviously we can report this in the normal way. So graphics details is the first of a series of reports that are available to you. Here's where we can enter in the information about the part, and if we show that preview, you can see the dimension applied there. Obviously it would make sense to have your tolerance bands and your tolerancing in the as applied to the dimension to be the same. Once we get to the more conventional looking report, tabulated dimensions, you can see that we have one dimension in this inspection, and because my revised tolerance of 2 microns is still applied, we have a fail. So that's scanning and best fitting. Thanks for listening.